This is a video recording of the slideshow to discuss some of the properties of nanomaterials. This slideshow was originally created by the Pennsylvania State University, and also I added some information from NanoSense, the basic sense behind nanoscience. In class, I'm going to have you watch this video, but I won't watch it here in this section. Here I just want to really go over some of the slides and information. So it's sometimes better to be little. As we'll see, new doors open up at the nanoscale. New things happened and new opportunities become accessible for some really interesting materials. So are you a nanobit curious? What's interesting about nanoscale? Nano-sized particles exhibit different properties than larger particles of the same substance. As we study phenomena at this scale, we learn more about the nature of matter, develop new theories, discover new questions and answers in many areas, including healthcare, energy, and technology, and figure out how to make new products and technologies that can improve people's lives. The important thing that I want to go over is the size-dependent properties, or how do properties change at the nanoscale. So properties of materials basically describe how a material acts under certain conditions. And types of properties are optical, which is color and transparency, electrical, which includes conductivity, physical, which are things like hardness and melting point, and chemical, which are reactivity and reaction rates. So most of what we know and have grown up with are the properties that are usually measured by looking at large aggregations, like 10 to the 23rd aggregation of atoms or molecules. So those are, many molecules together. But what happens when you have very small aggregations of molecules or nanoparticles? In this PowerPoint, we're going to be talking about most of these, not so much electrical properties, but they also change drastically at the nanoscale. How are nanoparticles different? Well, they're very small in size. It's obvious, yet the impact is tremendous. They have a super high surface area to volume ratio, where most of the atoms of that particular particle are on the surface, and this creates a unique surface environment for most of the atoms, which then translates to unique properties. Surface forces dominate over bulk forces. So for example, gravity is not important. Quantum mechanical effects are important, and wave properties of light are important. Some other unique attributes are that sizes are corresponding to the basic biological structures and also to macromolecules. The unique chemical bonding and configurations are possible, size range in which the molecules can self-assemble, and working at the nanoscale has caused us to learn new ways of seeing our world. So the instrumentation has been vastly improved. The very small size of nanoparticles can fit many nano-sized particles together with little space in between. So you really cut down the space between the atoms or the molecules. They can get a large number of nano-sized things per volume or area. So some of the advantages are a higher reactivity, or because of the surface area. For example, if you have like a catalytic converter, you can use a lot less platinum if you have like nanoparticles on there than if you just coated it with platinum because of the surface area. You can do more, lower material costs because you need less material, and possible property differences just due to the nano size. An example of an impact of this attribute getting smaller and smaller is the huge number of nanoscale transistors that are possible today compared to years and years ago. So here's an example of an older version where you could see that the number of transistors you could probably count them. And in today's chips, there are literally billions of transistors that you couldn't even see or count with the naked eye. Scale changes everything. So there are enormous scale differences in our universe. At different scales, different forces dominate. Different models are better to explain the phenomena, like the quantum model versus the classical